Welcome to Planet Pulse, where the world's secrets, stories, and wonders come alive. Let's dive into the heartbeat of our planet. In 2017, the Earth encountered a very weird object. We didn't know it at the time, but our planet had been visited by something that had come from deep in the void of outer space, from another star. It was unlike anything we've seen before, and, it's taken us years to figure out what that object really was. Now, in 2025, it's all happening again. Another strange visitor is approaching our sun. Only this time, we can see it coming. And, honestly, things are about to get even stranger. Let's start at the beginning. This is Oumuamua. It's the first interstellar object ever detected, meaning that it came from another star. Then it spent millions of years traveling through space on its way to encounter our own solar system. But still, this one caught us by surprise. At the time we finally identified the object, it had already made its closest approach to the sun, and it was on its way out of the solar system back into the void. Oumuamua gets its name from the Hawaiian observatory that first discovered it. Originally they thought it was just another comet, but on closer inspection, they realized it didn't have the signature tail of a comet that was passing through the solar system. So, it must be an asteroid. Only, this object was behaving too weird to be just another space rock. It was moving too fast. This is the first indication that we are looking at an interstellar object. Everything inside our solar system is caught in the gravity of the sun. All of the planets, comets, asteroids, we are all just spinning around this incredible force of gravity, and the only way for us to get out of the solar system would be to accelerate, to reach escape velocity. That depends on how close you are to the sun, but from the Earth, escape velocity would be about 42 kilometers per second. When we first spotted Oumuamua as it passed beyond Earth's orbit on its way out of the solar system, it was moving at 87 kilometers per second, way too fast to be caught by the sun's gravity. That's what we call a hyperbolic trajectory, and what's really interesting is that before Oumuamua passed by the Earth, it flew so close to the sun that it was actually inside the orbit of Mercury. And what's more interesting is that such a close encounter with a powerful force of gravity should have slowed the object down. But what we observed was that as Oumuamua moved away from the sun, it actually accelerated out of the solar system. This is where the name Oumuamua comes from. In the Hawaiian language, it means the first to reach out, or the first distant messenger. Typically, we condense the translation to just mean scout. So, we've got layers of weirdness here, and this is just scratching the surface. If the object in question was just an interstellar asteroid, also known as a rock, then its movement should be governed by the laws of physics. And physics says that passing by the sun would have slowed it down. So if that didn't happen, then it means some other force, coming from inside the object itself, had to have acted to change its velocity. That means it is physically impossible for this object to just be a rock. It has to be something else. And the next level of weirdness is that not only was Oumuamua traveling through space in a way that we've never seen before, it also looked really strange while doing it. When we try and make an image of something in outer space, all we really have to go on is the amount of sunlight being reflected off of it. Giant bodies like Saturn and Jupiter reflect a giant amount of light, and that allows us to see them clearly even though they are really far away. But when it comes to something relatively small, like an asteroid, all we see is the faint little blip of light reflecting off that object. Most asteroids are not very reflective because they are just rocks, and they are mostly round in shape, so we expect to see a relatively consistent and dim reflection. Oumuamua did something unexpected. For one, it's a very bright object, highly reflective, indicating that it's probably not made of rock. And thing two, as we observed this light in the sky, it was not consistent. It was pulsing from bright to dim and back again once every 7 hours, meaning that the object can't be round like an asteroid. We are seeing a long side and a short side. This led astronomers to the unlikely conclusion that the object was probably long and narrow like a cigar, and it was slowly tumbling end over end as it moved through space. Although this could also be explained by an object that was saucer-shaped, wide, and flat, and thin, also tumbling as it moved. But telling people that you saw a flying saucer that came from another star might start to sound a little crazy, unless that's actually what happened, in which case, aliens. Is Oumuamua an alien spacecraft? This is the point where the History Channel would try and tell you that it is, and it could be, but we are just here to present what we know, and let you draw your own conclusion. But yeah, this is pretty weird. People get hung up on the way Oumuamua looks, and it is unusual. But don't forget, it's actually the object's unexplained change in velocity that makes it so strange. It's what gives some credibility to the alien hypothesis. So, here's the deal. It's normal for a comet to accelerate when it passes by the sun because comets are essentially just big chunks of ice that come from deep out in our solar system, the Oort cloud. There's all kinds of weird random frozen stuff out there. It's like the bottom of your deep freezer. Occasionally one of them loops through the inner solar system, and as it gets closer to the sun, the ice begins to transform into gas. This is called sublimation, which is different from melting because the ice never becomes liquid. It goes straight from solid to gas. That's what gives the comet its fuzzy halo, also known as the coma, and its long tail. There's also a lot of dust that gets released as the ice sublimates, too. Anyway, the point is that all of the off-gassing will act just like a thruster on a spaceship. So, if the sun is heating one side of the comet, it's going to shoot more gas out in that direction, and the force will push the object and change its orbit and velocity. But Oumuamua had none of these comet-like visual characteristics. No coma, no tail, no visible outgassing of any kind. Yet, it behaved in a very comet-like fashion, which would lead some people to believe that this actually was a spaceship with thrusters. Let's talk about where Oumuamua came from. Its direction points to the star Vega. It's the brightest object in the constellation LRA, which appears over the northern sky. Vega is not just some random star. It's been studied extensively by astronomers over many years, and it's often referred to as the most important star in the sky after the sun. That's interesting. 14,000 years ago, Vega was actually the Earth's northern pole star, the North Star, a stationary point of light in the night sky that has been used for navigation probably since the dawn of man. The North Star changes over time as the Earth slowly wobbles around in space. Right now it's Polaris, but it will transition back to Vega sometime around the year 14,000. Now there's no evidence to say that Oumuamua came from the Vega system. It just came from that direction, which coincidentally is the same direction that our own solar system is currently moving. So, as much as Oumuamua hits us, we also kind of hit it. We'll get more into how things move through the galaxy in a minute. As Oumuamua loops around our sun, it starts flying directly towards the Earth. This is where some would say that the coincidences really start to pile up. This strange object coming from a distant yet historically significant place in the galaxy, behaving in this odd and unexplainable manner, and it flies right past us. Close is relative in space though, but it was still 24 million kilometers away at the closest approach. For scale, the moon is 400,000 kilometers away, so roughly 50 times the distance to the moon. But maybe an ancient alien probe from an advanced civilization can still see us from very far away. This is where our telescopes spot Oumuamua for the first time, a few days after the closest approach to Earth, as it's already on its way back out to interstellar space. So, as close as it came, we never really got much of a chance to study Oumuamua, or even figure out just what exactly it even is. There have been ideas thrown around about sending a probe to catch up with Oumuamua and trying to study it, but the object is moving so fast and it has so much of a head start that no chemical rocket engine could possibly chase it down. We'd have to work out some complex bit of orbital mechanics, where a probe would just fly to Jupiter, use a gravity assist off the planet to fall into the sun, then ignite its engines as it flies past the sun to slingshot itself out of the solar system in the same direction as Oumuamua. And that's not going to happen. If Oumuamua had been the one and only interstellar object we'd see in our lifetime, then something like that might have been worthwhile. But shortly after that first encounter with a piece of the distant galaxy, something weird started happening. We were visited again in 2019, a second interstellar object was spotted. This one was named Borisov after the amateur astronomer who first discovered it. Just like Oumuamua, Borisov was coming in on a hyperbolic trajectory, too fast for the sun to capture. And Borisov originated from the same general direction in the northern sky, this time flying out of the constellation Cassiopeia. Unlike Oumuamua, however, Borisov is definitely a comet. It looks like a comet. It behaves like a comet. And as far as we can tell, it's made of very similar stuff as the comets in our own solar system. Still pretty cool, but nothing mind-blowing. Though it is interesting that we very abruptly went from seeing 0 interstellar objects for the entire time we'd been observing the night sky, and then we get 2 of them in 2 years, and then there was 3. This is our newest visitor, 3 Atlas, meaning third interstellar object. and it was discovered by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, which is an autonomous robotic survey that detects near-Earth objects. It was spotted on July 1st at a distance of 4.5 astronomical units away from the Sun. An astronomical unit, or AU, is the average distance between the Earth and the Sun. We use that like a solar system measuring stick. So 3 Atlas is 4.5 times further away from the Sun than the Earth, which means it's just past Jupiter, but still really far away from Mars. The cool thing about 3 Atlas is that we caught this one on its way into the solar system. So, we are currently watching it approach the Sun for the first time. What stood out initially about this object is that it's really big, and it's moving really fast, much faster than Oumuamua, and it's coming from an entirely different direction. While we basically hit Oumuamua and Borisov head-on, Atlas is coming in from the side, like a T-bone collision. And that means Atlas originated in an entirely different part of the galaxy, somewhere distant, ancient, and very unlike our own cosmic neighborhood. Okay, we're typically used to seeing our Milky Way galaxy from this perspective, top down, and that's us right here, pretty much halfway in between the core and the outer rim. But from our perspective, the galaxy looks more like this, a side-on view. We've got a big sphere-like core, also known as the bulge, and it's surrounded by a relatively flat disk of stars and planets and gas and stuff that's all swirling around like a spiral. The vast majority of those stars are located in the very center of the plane. We call this the thin disk. It's where our sun is located, but just above and below the thin disk is a much less dense and more diffused layer of stars known as the thick disk. Because there's less star-forming action up here, objects in the thick disk tend to be much older remnants from the early days of the galaxy. And then outside the thick disk, there are these random pockets of star formations that we call globular clusters. But those are probably really weird, but we're not going there today. The reason you need to know this is because 3 Atlas appears to have originated from the thick disk. And if so, then this might be an unfathomably ancient object. On the high end, it could be more than 7 billion years old, older than our own solar system. So, that alone makes 3 Atlas a very interesting object. But there are 2 more factors at play that deepen the intrigue even further. One is size. This object is really big. Initial reports put the diameter at up to 20 kilometers across. And as we continued to observe Atlas, we started to understand a little more of what we were looking at. It quickly became clear that this object does have a coma surrounding it, a cloud of gas and dust, meaning that it's not a solid object, like Oumuamua. It's actually an interstellar comet, like Borisov. So the coma is 20 kilometers wide, but the nucleus, or the solid mass of frozen stuff in the middle, could still be as big as 11 kilometers across. That would be 10 times the size of Oumuamua and 5 times the size of Borisov. So they are getting bigger. And thing number 2, this is probably the strangest fact about Atlas, is its trajectory. Since this object is hitting us from the side, it's going to have the opportunity to pass by several planets on its way through. The object's closest encounter will be with Mars, coming within about 28 million kilometers. Then it's going to pass relatively close to Venus, about 97 million kilometers. And on its way out, 3 Atlas will fly by Jupiter at a distance of just 53 million kilometers. So it's getting in some good quality sightseeing on this trip. But coincidentally, 3 Atlas is going to miss the Earth entirely. We'll actually be on the opposite side of the Sun as the comet makes its way through the inner solar system. That means our telescopes will lose sight of the object in October this year, and we won't be able to see it again until December, at which point it will have already made its closest approach to the Sun, and will be on its way out of the solar system. Now, just like with the strange behavior of Oumuamua, some would say that the planetary grand tour of 3 Atlas is no coincidence that Bauwiden so beinsure enton de coincidence that it might be the intentional behavior of an alien probe, one that is trying to learn as much as possible about our solar system while at the same time avoiding close observation from the only inhabited planet by hiding behind the Sun. Even with an open mind, that one feels like a pretty big stretch. If an ancient alien species actually sent a probe all this way across interstellar space that traveled for billions of years and had the opportunity to check out a planet that was covered in life and home to an advanced civilization, but then they just shy away from us at the last minute, Anyway, the cool thing about 3 Atlas is that we still have a couple of months to observe it as it gets closer and closer to the inner solar system. So, in time, a lot of the mystery will be converted into knowledge. And unlike Oumuamua, we might still have a shot at intercepting Atlas. Now we probably can't get anything built and launched from Earth fast enough, but we do have pre-existing spacecraft in orbit around Mars and Jupiter. So, there is a potential scenario where one of the Mars orbiters moves out to try and get as close to Atlas as possible. There's even a scenario where the Juno spacecraft departs from orbit around Jupiter and meets up with Atlas in deep space next spring. That's unlikely to happen, but it would be cool, if for no other reason, than to just know for sure what it is we are looking at. If we could have done the same for Oumuamua, then we'd probably have a lot more answers and a lot less questions today. But even without sending a probe, we still have some pretty good ideas. So, assuming Oumuamua wasn't an alien spaceship, it could still be a comet. If a comet is just a chunk of frozen stuff, then there's no rule about what that stuff has to be in our solar system. From the comets that we see are typically made of frozen water which sublimates into gas and creates the signature tail, because water vapor is generally easy to see, like steam for example. But not all gas is so visible. Nitrogen accounts for nearly 80% of the air we breathe. It's colorless, odorless, and generally imperceptible. But it does make plants grow, so it's important stuff. And there's one very familiar object that's made almost entirely out of nitrogen. It's Pluto. The object formerly known as a planet. Most of Pluto's surface is nitrogen ice, which is a lot of the reason why Pluto was considered to be a planet in the first place. Because frozen nitrogen is highly reflective. So, when you look through a telescope, Pluto appears big and bright, but it's actually less than 2,500 kilometers across. It's much smaller than our moon. Now imagine this scenario. Pluto gets struck by a giant asteroid or a rogue planet, and it shatters into jagged little bits. One of them gets launched towards the sun at incredible speed. Now what we've got is a chunk of frozen stuff moving from the outer solar system towards the interior. Essentially a comet by most definitions, except this one is made almost entirely of nitrogen ice. So it's going to start melting or sublimating technically as it approaches the sun, and the ice will convert to gas. But because nitrogen is invisible and unreactive, we won't actually see any coma or tail coming off the object. But that doesn't mean it isn't there. It is. And then, as the shard of Pluto gets closer to the sun, more and more gas is released, and the object's natural thruster system gets fired up. And in this whole chaotic mess, the sun's gravity ends up flinging the shard straight out of the solar system and into the void of interstellar space. That's a MUA. If that type of scenario played out in some distant star system, maybe the Vega system, and ejected some weird shard of frozen nitrogen from a smashed dwarf planet, and then that object hit our own solar system and flew past our sun, then it probably would have looked and behaved a lot like Oumuamua. Or aliens built a 100-meter-long cigar-shaped tumbling space probe and flung it at our solar system, only for it to pass kinda close to the Earth, but not actually very close, and then just fly away without really doing anything at all. And that's why it's really important that we get to spend so much time studying 3 Atlas, because it means we get to eliminate a lot of these known unknowns. We stand to learn a lot about how the universe actually works. The process of nature on a scale that is so unfathomably more massive than our own minuscule little existence on one pale blue dot. So the most interesting stuff is still to come. Stay tuned. Thank you for watching. If you enjoyed this video, please like, share, and subscribe for more content like this.